very happy to be here with this great panel. Super excited because they all bring in a very different perspective to cybersecurity. And I'll start with May Wang. The way I think about her expertise is IoT security, which is very, very unique because you're talking about securing millions and billions of devices, very diverse. So the model that you have to take to secure that requires AI ML. So she brings that perspective. Look forward to hearing that. Ram has a completely different perspective on it. He applies Deception 2.0, combines that with AI ML to detect the bad guys. Now, perfect prevention, while a noble goal, is not probably achievable, right? So we have to have high fidelity detection. Ram will help us understand some of those things. And Amit, I guess amongst all of us, he probably has the most experience dealing with large amounts of data, 50 billion transactions every day across 100 data centers. Data is the fuel of ML AI, and Amit will help us with the issues related to that. So super excited. Welcome.
Thank you.
So let me start with, I think, some of the topics that Rahul actually covered. AI, hype versus reality. I mean, we've been here before, right? 60s, Turing test, and then the AI winter. Some people say it's different this time. Is it? Amit, what's your?
Yeah, sure. So, if you boil it down, AI today is essentially deep learning, and if you boil it down, deep learning, it's one-trick pony. It's back propagation, right? That was invented by Hinton in 1986, and it took 3 decades for compute power to catch up, for us to be able to apply that to practical problems. And what are those practical problems? Well, computer vision is one. Computers have gotten very good at pattern recognition. Your iPhone unlocks by looking at your face, and the general consensus is that machines can now recognize patterns and faces with an error rate of 3% versus humans at 5%. So fast forward to today, that's led to this big resurgence where people are asking if machines can do a better, faster, cheaper job at pattern recognition, what other domains can we apply to? But there is a big hype cycle. I think there's an old 70s statement that said, the state of AI today is such that you can have a machine make a perfect chess move while your room is on fire, right? And that just about summarizes where we stand today in terms of context, right? You can train machines to do very specific tasks, but that whole notion of having a context and a little bit of human awareness so that they don't trip on when the environment changes a bit is just lacking. So that'll be the area where a lot of focus and research will happen.
Remind me of a joke I think we used to have when we used to do natural language processing. So computer is talking to a human, and human says, "What do you want?" Computer says, "Natural language processing." And human says, "When do you want it?" The computer says, "When do you want what?" Right? So it has no context of what it was. So talking about context. Very interesting. May, what's your take? Hype, reality, different this time, or AI winter is coming soon?
Let me share a story to give you a sense about the reality of AI years ago. When I just started in graduate school, and I was wondering what research area I want to go into for my PhD. And I have a very smart landlord said, "May, let me give you a piece of advice. Whatever you go into, don't do AI." Because I have a good friend who got his PhD in AI from Stanford, and for 20 years, he couldn't get a decent job. And myself, I majored in physics for my undergrad, and only then I learned there's another subject that can make me even more jobless.
Okay, no, that's.
But physics people are the smartest people on earth. So.
I second that, I think. So that's great. I think, so we've got the sense of hype versus reality in AI. And Ram, I'd love to get your perspective on hype versus reality of AI in cybersecurity, right? Specifically to this. And I'll give you a quick anecdote. I was presenting at RSA conference, more than 1,000 people out there. On this topic, I asked them, how many people are getting value out of AI, ML in security products? not one person raised his hand. I was shocked.
Yeah. I think,
What's the real deal here?
yeah, so I think AI certainly has a lot of value. We see it in our daily lives, social media, whatever, things like that. In cybersecurity, I think the tone of your question might have been very too precise in the sense that are you using AI in itself to solve a problem? Because one of the requirements in cybersecurity, which is unique from much of other everyday life, is there is a need for precision and speed. So tolerating a lot of false positives and things like that is a heavy burden on the security space. You cannot be almost right. So either you're letting the bad guy in or keeping the good guy out. So there is a better way of thinking about AI in cybersecurity is how can we leverage AI to make either existing technologies or new technologies work better, perform better. So for example, anomaly detection. Anomaly detection is wonderful, but anomaly detection essentially throws up lots of false positives because not every anomaly is actually a security problem.
Right.
And so things like that. So I think, yes, it's. I don't think there is hype, there is value, and I think it's here to stay.
It's here to stay. Amit, your take?
Yeah, I mean, so yesterday I heard a very nice statement that said, if ML is a rocket, data is the fuel, right? And that's a good summary. I think for cybersecurity to effectively use ML or AI, three things have to come together, and that's true for any AI-based problem solving. The first, of course, is the data set, right? If you don't have the fuel, it doesn't matter. The second is sort of the data engineering and the data science aspect of things, right? Can I sanitize my data? Can I plumb it? Can I feed it? Can I choose the right models, feature engineering, all of that stuff, right? A third and very important component that people miss is domain expertise, right? If you're trying to use AI to detect cancer, you better have radiologists that are really good at working with your data science and data sets, right? So, I'll give you a Zscaler example. We don't just go with hype. You mentioned that we have 50 billion internet transactions going through the service daily. To put that in perspective, Salesforce.com does about 5 to 6 billion transactions on their platform. Now, it's not an apples-to-apples comparison because, all enterprise traffic, we sit between enterprise users and destinations, so everything that a user generates goes through us. So net, you get the data, and then we have all the data engineering and analytics teams that are solving very specific problems. And this, we heard from Silence around specific problems that you can solve. And without taking too much time, I'd say for us it falls into three categories. One is around security, right? We do things like user risk analysis. If you're seeing all transactions between a user and a destination, just like you have a credit score, you can come up with a risk score and say, this user's behavior is a little more risky compared to this person. And then you can normalize that based on vertical, industry, et cetera, right? The second class of problems that I think cybersecurity can leverage AI and ML for is around data exfiltration, right? We kind of discuss what's normal, what's abnormal. I'll give you a very specific example. We use ML techniques to detect DNS tunneling. It's a very sneaky way for traffic to kind of leak out of your environment without people realizing. And the third area is around, I'd say, content classification, right? There's so much dynamic content being generated, whether it's new ransomware strain. There was a question, like, how can I detect the next ransomware attack? Well, you should be able to detect variants of this strain versus that strain, right? When you're seeing thousands and hundreds of thousands of new PDFs and Word documents, you should be able to say, here's a variant, right? That looks malicious. And similarly, basic things like even destination classification, right? We have customers who want to block gambling. How do you stop a new March Madness site that has popped up, right?
Right.
So you should be able to look at lots of different gambling sites and say, hey, this new one that popped up in the last 1 hour is also gambling. So those are some of the domains where there are specific applications of AI and ML for security.
One point to add to that, I think one of the challenges that cannot be overlooked is in the credit card world, for example, it's very easy to classify data, take lots of data, for example, build models, things like that. In cybersecurity, there's not enough labeled data. There's not, to understand APT attacks. So building supervised learning is very, very hard.
Right.
So that's why you end up with lots of false positives in the enterprise, in the cybersecurity domain, which many other domains don't have that problem. So that's an important distinction.
Yeah, I think this makes total sense. Lack of labeled data is root of all evil, right, for us. So, May, your perspective on use cases, because I think it's very different from probably everybody else on this panel. IoT security, what are the opportunities you see and challenges?
Yeah, we found for the past 4 years, we've been focusing on IoT security, basically trying to secure all the connected devices. And we found AI is an extremely effective tool for that, for probably two main reasons. One is for these devices, they're generating huge amount of data, as Amit just mentioned. It's, our human being learn from experiences, but these algorithms learn from huge amount of data. So all of a sudden, we got this huge amount of data that we either couldn't get before or couldn't get in real time. So that helps a lot. And also, for these IoT devices, they're purposely built for a fixed set of functionalities. They're not as complicated as human being. If you ask for what's May's normal behavior, I don't even know myself. How do you expect AI to figure out May's normal behavior? But for these IoT devices, they actually have a fixed set of behaviors. Their patterns are relatively predictable. So we found, and also the challenges for these IoT devices is scalability. There's so many IoT devices and so many different kinds of IoT devices. And we found that's exactly where AI can help us a lot, because they have relatively predictive patterns, so we can easily teach machine learning to be smart, to figure out the patterns, or the machine learning can pick it up by itself and with very good accuracy, and at the same time, it can easily scale up.
Got it. It seems there's a theme emerging here, if I may summarize this. I think we need to be very specific about what problem are we solving using AI. There is no generalized AI silver bullet that will make you more secure. And vendors, when they talk about specific problems that they're solving, you can have some confidence that they know what they're talking about, right?
And domain expertise.
And domain expertise, absolutely. On domain expertise, actually, this is a question that keeps coming up. With deep learning, I believe all the feature engineering which requires domain expertise is going to go away. Is that true? I mean, I just throw raw data, the neural network just learns everything itself and does not need domain expertise? What's your...
The bad guys have learned how to crack captchas by using deep learning, right? So I think captchas in big danger. So I think again, it depends on the specific use case. I mean, so captchas is a good example. So you probably don't need much domain expertise in any particular industry to actually apply deep learning. So you have labeled data, and as long as you can label the data, you can learn something. So the question is, what kind of data set are you applying the technique towards? That is, so I think that's the real distinction. So it's not a one way or the other issue. It's a question of what is the problem that you're trying to solve, and how are you going to solve that problem using deep learning.
Got it. I think there's a question that, there's a point that was raised just now about adversaries, bad guys using AI, ML. Just a great topic. I think it makes for a good movie. I'm curious if you guys have seen that, or do you think that's a real threat? Rahul said it is. Would love to get your perspective.
Absolutely. Look at encryption. Good guys did encryption to keep stuff out from the bad guys. Now bad guys are doing encryption and asking for money in return for getting back your own goods. So turnabout is fair play for the bad guys. So certainly they will use AI and ML to work against you in many ways. In simple things like anomaly detection, for example. If they know how your anomalies are working, they can actually create anomalies and keep you busy chasing that while they go do something else. For instance, finding ways to penetrate into systems. They can probe systems using AI techniques much, much faster than a human being can probe and create variants, creating variants of malware, for example. AI can create many more variants of malware than human beings can create themselves. So there are many, many possible ways in which AI can be used to actually attack good guys. So I think this is a race that will be going on. Right. And I think encryption is a very good case study to actually figure out, this is a technique, and techniques are fair game for everybody to use.
Amit, are you seeing actually bad guys using AI on your radar?
Absolutely. And I think, in many ways, cybersecurity is like a Tom and Jerry cartoon, right? The same open source tools that are available to the good guys can be leveraged by bad guys.
Absolutely.
I'll give you some specific examples. We run cloud sandboxes, right? So whenever we see a file pattern that we have no knowledge about, we can detonate it inside a virtual machine, analyze its behavior, and come up with patterns. And over the last year or so, the stealthy techniques that have been deployed have become so sophisticated, right? It used to start off with basics like, you try to detonate a file in a sandbox and it goes to sleep for 5 minutes and the sandbox would give up. I mean, that's just basic. Then it started trying to detect whether a real human is actually trying to open it by looking at mouse movements. One time we found a piece of malware that was trying to look at the recent documents that you had opened in your Microsoft Word to then detect that this looks like a real laptop from a real user as opposed to kind of a fake VM where you're trying to catch it doing something bad. And so, at the end of the day, this is kind of like a Turing test, right? If a piece of malware can figure out whether it's interacting with a human or not, and if it is interacting with a human, it does something bad. If it's trying to interact with a machine that's trying to catch it, it goes silent. You can end up with scenarios where you have pretty stealthy malware, right? So absolutely, I mean, it's fair game, right? It's measures and countermeasures and countermeasures, and that's why security has gone from 12 vendors to different vendors, right?
So yeah, I think that's why using AI as an assist is a big deal because I think that's the useful story. So you use something else, for example. In the case that Amit just described, if you have decoys and things like that, you can let the malware run and then figure out, who he's touching, and then use AI techniques to actually go catch the attacker. And so I think there is a symbiotic play with other techniques rather than looking at AI in itself as a panacea. I think that's probably the best use of AI.
So AI is a complement to human, not a panacea by itself.
Not necessarily human, but also could be other techniques.
Other things.
Yeah.
But a question for you, actually, so one of the slides Rahul presented had IoT thing being attacked by AI from adversary, and it was about diagnosing somebody's diseases. So you were into IoT. Do you worry about that, adversaries using AI against IoT security devices?
Yeah, we definitely see, as everybody has mentioned, we definitely see hackers have been using lots of advanced technologies, AI and cloud and open source and et cetera. So that's why it's definitely a race, and that's why security provides job security. It's a race forever, and what we see is that in order to use AI, actually, it's still AI itself has some intelligence, but it still requires, for example, when you feed the data, it actually requires some human knowledge, requires common sense that the AI doesn't have, and also whatever results AI generates, it also requires human knowledge and human expertise to interpret these results and to how do you understand all these insights that AI is providing.
One more sobering thought. There is so much surface area available for attacks that you don't even need AI to go find these attacks. So there is a lot of work to be done, and all the way from, can you attack the crop system, to can you attack hospitals, to things like that, to milking cows. Everything is done by some automation, which is all subject to AI attacks. Actually, subject to attacks. You don't even need AI. Many of these are waiting for somebody to come and trample on them. So.
Got it. Slight segue, and I think an important topic, role of regulation. I mean, there are two dimensions to this that I see. There's a large amount of data that we have to collect, so that seems to have privacy implications. The second part of it is the Elon Musk factor of AI going haywire and RI on us, right? So regulations that manage the ethical part of AI. So Amit, I'll start with you. You deal with large amounts of data, so do you think this is an issue, and what's your perspective?
Yeah, absolutely. And some of you might have heard of GDPR and some of those other regulations that are coming along. I think users have a right to own the data, right? And they have the right to make enterprises forget all the data they have collected. All the hype around Facebook is just kind of making people more and more aware. For Zscaler in particular, again, we sit between users and destinations. For us, data is just metadata logs, right? User went to Facebook using an iPhone from a San Francisco location. We're not storing content. But it's very important to be able to guarantee that all data that you collect is well known, is stored in a compliant way. It's not scattered across 50 different machines or infrastructure, AWS, Azure, right? You need to know exactly where data is. You need to be in a position to govern it. You need to be able to purge it if needed. If there's PII, you need proper tools to tokenize, encrypt, and all of those types of things. So in our case, for example, because we deal with large enterprises, the GEs, the Philips, the Nestles of the world, you might have a Nestle that says, hey, my data should never leave Europe, right? So by design, we guarantee that their logs are always written to disks that I can point to in their locations that they control. A GE might say, I might want my logs only on US soil. And although we operate across 100 data centers, when it comes to writing logs, which is the sensitive aspect, we can guarantee by design that it is in very well-defined locations and nowhere else, right? So that's an important part. And then, kind of the follow-up question around Elon Musk. Look, Musk is a very bright guy, right? Are we at a point where we should fear the singularity and machines taking over? If you ask practitioners, they deal with such basic issues, right? Where machines are still having a problem identifying a dog versus not a dog. We're still very far away from this conscious awareness where we should be scared. And the other thing around jobs, I'd say, whenever there's a technology revolution, right, whether it's the industrial revolution or something else, old jobs get eliminated, new set of jobs get created. And the fear is always in the transition because there's a gap, right?
Got it.
But eventually, humankind is more productive. So
I think one point on regulation is important. It's not only regulation of protecting the data and things like that. The question about regulation is also about liability assessment.
Right.
And I think that's a very important question. Who is liable in case there's an AI system that's making a decision that causes a certain action? And I think that's where I think there's a lot more work needs to be done. And if you're driving a car and it hits a wall and something happens to you, it's still not clear who's going to do that. The same thing is going to apply now to AI systems because AI systems are going to govern how defenses work in various companies and things like that and so on.
So May, do you have a perspective on that? IoT security plays directly into that. I would imagine you face it today.
Yeah, we definitely see regulation as a double-edged sword. On one side, we see one of there are two forces that can push forward most effectively for people to adopt cybersecurity solutions. One is hacking incidents, and the second is regulation, government enforcement. But on the other side, because we are in, ZingBox is in many large hospitals, and we all know that in healthcare there's heavy regulation. And because of that, HIPAA compliance and et cetera, we do see there are lots of devices have been in the field for 10 years, 20 years without any patches. Nobody wants to touch it because they're so afraid they have to go through this HIPAA compliance more. But so it's definitely not a science, but more of an art. And right now, because we work a lot with hospitals, we actually have been working very closely with FDA and with Department of Human health and human services. And we do see that these regulation bodies have been very proactively working together with the industry, listening to input, and trying to come out with reasonable guidelines, best practices, and also new cybersecurity regulations for medical devices.
Great. So I'd like to invite audience questions in a minute. Before we get there, in 15 seconds each, one prediction that you would make for role of AI in cybersecurity in next 3 to 5 years. It's a hard one, and something that's not obvious, right? So if I may ask, Ram, you can start. One prediction.
I think prepare to hear the word autonomous a lot with security. I think driverless security is coming to a company near you because I think human beings cannot react fast enough to threats. I mean, I often say when the bad guy is attacking, the good guy is asleep. So you need systems to respond by themselves, and they have to respond intelligently. It's not just about turning something on or off. So I think in the next 3 to 5 years, there's a lot of autonomous security solutions in the market.
So driverless security, okay? We'll come back in 5 years and see where that is at.
So my prediction is within 3 to 5 years, I bet every single security companies will have an AI product.
Well, I think we are there already.
Not every one of them. Some of them claiming they have, but they don't really have.
Okay,
so we hope in 5 years they actually do have a working AI product.
The internet is full of cheat sheets on how to identify AI in your vendor. So be sure to read that.
Right. Amit?
Yeah, I mean, I think I'd say the world of SOC, Security Operations Centers, right? Just like your call centers have been vastly getting simplified, security operations centers that deal with a lot of data, and there's alert fatigue and people are missing stuff. That's an area where you're going to see AI and ML be able to analyze data, classify, and make better decisions than humans have been doing.
Awesome. Now we take questions from the audience, please.
Yeah, my question is if you could comment on...
Can you maybe stand up and speak out loud for everyone?
Okay. This is Sandeep. I'm from IBM. My question is, I'm blessed with a very loud voice. Could you comment on AI and ML role in cybersecurity, how the state actors, the defense departments, and spying agencies are currently using, or what is your view on, where it goes from here?
I think if they tell you, they'll have to kill you, I guess.
I was just going to say that. I have no idea because I've never been on the inside of those things. I'm sure they know a lot about me, but I know very little about what they do. So,
Amit, any one of you has insights into the 3-letter agencies and their usage of AI?
I mean, yeah, you can watch Homeland and, you can get some ideas. But, I mean, I think, again, these things are double-edged sword. Everything is available to the open source community. Generally, some of the secret agencies seem to be a couple of years ahead of what's available in the public domain. So,
yeah, it's about access to data. I mean, if you have lots of data, then you can make more conclusions. So.
And also about how much money you put into it, the resource.
Question here? Yeah, please.
Okay. So, in fact, Ram and Amit, I think you mentioned this topic in I think one of the discussions. So, there's a shortage of the labeled data. I think you mentioned, and particularly in case of the catastrophic risk, something which is really important. So, how do you handle that problem in machine learning? Particularly for security.
Yeah, so that's why I think AI is not really a panacea for those kinds of environments. So APTs, for example, in the security space, in cybersecurity, there's not enough labeled data. So you can't do supervised learning. So I think AI has an important role, but maybe an assist role. So that's why, for example, in our company, we're using AI in conjunction with deception to actually find malicious activity and things like that. So I think, unlike in the credit card space, where I can actually algorithmically figure out this transaction, I score a transaction. It's all about false positives. So how many false positives can you tolerate? And I think if you do unsupervised learning, then the problem is there'll be lots of false positives. So you need compensating technology code to deal with that false positive issue. So that's what you do in those situations.
And APT being advanced persistent threats.
Yeah, exactly. Yeah.
Perfect.
Yeah, one quick thing I'd add there is, obviously, and I mentioned that having domain expertise is a vital combination along with data science and data sets, right? And it's true for security because there's so many different flavors and variants. In terms of unsupervised machine learning, it has its applications, but one thing I'd caution is, you cannot be a vendor where if a customer asks you, why did this thing get blocked? And your answer is, well, I don't know, it's AI. You got to be able to provide a little more context and insights into why a particular action was taken, right? And I've seen that in a few cases, and we got to be aware of that. And that comes with a bit of domain expertise.
Okay, that's about sums it up. Thank you, everyone. Thanks to the panel for a fantastic discussion. Thank you very much.